Right now, without even knowing it, you are surrounded by gold. The smartphone in your pocket, the fillings in your teeth, the satellites beaming GPS signals to your car, even the treatment being used to fight certain cancers. Gold is not just a shiny metal locked away in a vault somewhere. It is woven into the fabric of modern life, and it all begins billions of years ago deep inside the earth. Today, we are going to follow the complete journey of gold, from a microscopic grain of rock buried kilometers underground to the products you touch every single day. Stay with me. This story is going to change how you look at the world around you. Before we go underground, it helps to understand why gold is so remarkable in the first place. Gold is one of the rarest elements on Earth. The entire crust of our planet contains only about 0.004 parts per million of gold. To put that in perspective, you would need to process roughly 250 tons of average crustal rock to collect just 1 gram of it. In fact, scientists believe that most of Earth's gold sank to the planet's molten iron core billions of years ago, pulled down by gravity. The gold we mine today was largely delivered later by asteroid bombardments that pummeled the early Earth around 4 billion years ago. But rarity alone does not explain gold's value. Gold has a set of physical properties that make it almost uniquely useful. It does not rust. It does not corrode. It conducts electricity exceptionally well. It is the most malleable metal on Earth. A single ounce of gold can be hammered into a sheet covering more than 9 square meters, thin enough to see light through it. That same ounce can also be drawn into a wire stretching over 80 kilometers. These are not just impressive facts. As we will see, they are exactly the properties that make gold irreplaceable in modern technology. Gold is found on every continent on Earth, but it is not distributed evenly. It occurs in 3 main types of deposits. The first is at lode deposits, also called hard rock deposits. Here, gold is locked inside veins of quartz and other minerals, embedded in solid rock deep underground. These veins were formed millions of years ago when hot, gold-rich fluids moved through cracks in the Earth's crust and slowly cooled, crystallizing gold into place. The second type is alluvial or placer deposits. Over millions of years, erosion breaks lode deposits apart. Rivers carry gold particles downstream, where they settle on riverbeds and in sediments. This is the gold that early prospectors panned for in California during the 1848 gold rush and in Australia's Ballarat fields in 1851. The third type is disseminated deposits, sometimes called Carlin-type deposits, where microscopic gold particles are scattered invisibly through vast volumes of rock. These are among the largest gold deposits in the world today and require industrial-scale mining to process profitably. As of 2023, the world's top gold-producing countries are China, Russia, Australia, Canada, and the United States. The world's deepest operating gold mine, the Mponeng mine in South Africa, reaches more than 4 kilometers below the surface, so deep that the rock walls reach temperatures of around 66 degrees Celsius, and refrigeration systems must cool the tunnels to make them survivable for workers. Now let us get into the actual mining process. There are 3 primary methods used today, and the choice depends entirely on where the gold is and how concentrated it is. Open pit mining is used when a large gold deposit is found relatively close to the surface. Massive machinery, blast drills, explosives, and haul trucks as tall as a 2-story building strip away the overlying rock layer by layer, creating enormous terraced craters that can stretch for kilometers. The Bingham Canyon Mine in Utah, USA, is one of the largest man-made excavations on Earth, over 1 kilometer deep and nearly 5 kilometers wide. Underground mining is used when ore bodies are deeper or when the gold is too concentrated in narrow veins to justify surface removal. Workers drill and blast tunnels and shafts, sometimes kilometers underground, to reach and extract the ore. Ventilation, temperature control, and structural reinforcement make this one of the most complex industrial operations on the planet. Placer, or alluvial mining, is the oldest form, and it is still used today. Water is used to separate the heavier gold particles from lighter sediment, using sluice boxes, dredges, and suction pumps along riverbeds. While not as large-scale as pit or underground mining, alluvial operations remain economically important in West Africa, South America, and parts of Southeast Asia. Regardless of the method, the gold extracted at this stage is not yet usable. It is locked inside ore, mixed with rock, minerals, and other metals. It must now go through a transformation. Once she arrives at a processing facility, it begins a multi-stage journey to become pure gold. The first step is crushing and grinding. The raw ore is fed into enormous mills that pulverize it into a fine powder, creating a slurry. This dramatically increases the surface area of the rock, making it easier to extract the gold chemically. The most widely used extraction method is cyanide leaching, also called heap leaching. A dilute sodium cyanide solution is sprayed over large piles of crushed ore. Cyanide bonds with gold at the molecular level and dissolves it away from the surrounding rock, forming a gold cyanide solution that is collected at the base of the heap. The process was first introduced industrially in the 1880s and remains the dominant extraction technique today because of its efficiency on low-grade ores. The gold-laden solution is then passed through activated carbon, which absorbs the gold. The carbon is treated with heat and chemicals to strip the gold off, producing a concentrated gold solution. This is then subjected to electrowinning, passing an electric current through it to deposit the gold as a solid on steel wool cathodes. The resulting material, called doré, is a rough alloy containing gold, silver, and other trace metals. It is melted in a furnace at over 1,064 degrees Celsius, gold's melting point, and cast into bars. Final purification happens at specialist refineries. The Woolwell electrolytic process, developed in 1874, uses an electric current to dissolve impure gold and redeposit it as 99.99% pure gold, the standard known as 4/9 fine, or 9,099 gold. Each gold bar is now stamped with its weight, purity, and a serial number, and enters the global supply chain. So where does all this gold actually go? The World Gold Council reports that global gold demand across all uses reaches thousands of tons every year. And it goes into far more places than most people realize. Jewelry accounts for approximately 50% of total gold demand worldwide. Every culture on Earth has used gold as ornamentation for thousands of years, from ancient Egyptian burial masks to modern engagement rings. India and China are by far the world's largest consumers of gold jewelry. Electronics demos are the second major destination. Your smartphone contains approximately 0.034 grams of gold. That sounds small, but when you multiply it across the billions of smartphones in use globally, the numbers become staggering. Gold is used in the connectors, circuit boards, and chips inside your phone because it is a perfect electrical conductor that never corrodes. Corrosion on a connector, even microscopic, can cause signal failure. So, in precision electronics, there is no reliable substitute. Laptops, televisions, and even the airbag sensors in your car rely on gold-plated contacts for exactly this reason. Medicine is a growing and remarkable use of gold. Radioactive gold isotopes, specifically gold-198, are used in targeted cancer treatments, where tiny radioactive seeds are implanted near tumors to deliver localized radiation. Gold nanoparticles are also being actively researched as drug delivery vehicles, capable of carrying chemotherapy agents directly to cancer cells while reducing harm to healthy tissue. Gold compounds have also been used for decades to treat rheumatoid arthritis. Dentistry has used gold for over 3,000 years. Gold crowns and fillings remain in use today because gold is biocompatible, the body does not reject it, and because it is durable enough to withstand decades of chewing without cracking. Aerospace and space exploration rely on gold in ways that are as critical as any other application. NASA coats the visors of astronaut helmets with a thin layer of gold to reflect infrared radiation from the sun while allowing visible light through. The James Webb Space Telescope's primary mirror segments are coated in gold to optimize infrared light reflection. Virtually every satellite in orbit uses gold-plated electrical connectors because in the vacuum of space, where conventional repairs are impossible, reliability is everything. Architecture also makes use of gold. Gold leaf hammered to a thickness of around 0.1 micrometers, is applied to the domes of famous buildings around the world, including the Dome of the Rock in Jerusalem and the State Capitol building in Georgia, USA. Gold leaf resists weathering so effectively that properly gilded surfaces can last for centuries with minimal maintenance. From a microscopic particle in an ancient asteroid to the device you are watching this video on right now, gold has made one of the most extraordinary journeys of any material in human history. Approximately 212,000 tons of gold have been mined across all of recorded history. If you melted every single ounce of it down, it would form a cube just 22 meters on each side, smaller than a typical apartment building. That is all the gold humanity has ever extracted. And yet, in that modest cube is the story of civilizations, of technology, of medicine, and of exploration beyond our atmosphere. Next time you look at your phone, or slip on a ring, or fly on a plane, remember that somewhere, kilometers underground, someone drilled through ancient rock so that a few invisible atoms of gold could make their way into your hands. If you found that journey as fascinating as I did, hit like and subscribe, because there are many more of these stories to tell.